Okay, so turn to page 3 in your circle packet. We've got the first definition on a chord of what a chord is. It's a line segment whose endpoints are points of the circle. So why don't you jot down on this picture down here, that's a chord. This is also a chord. And we would call chords, since it's a segment, we would call it like CB with a line over the top, or CA with a line over the top, or COA with a line over the top, meaning starts at C, ends at A. A special chord that goes through the center, you know, is a diameter. So this chord is also called a diameter because it's going through the center of the circle right over there. So CA is a special chord called a diameter. And like we talked about before, diameter equals 2 radius. So if the diameter is 10, then the radius must be 5 because 2 radius equals a diameter. Let's see. In a circle or congruent circles, congruent central angles. So I tried not to make these vertical angles, but I did want to make them congruent. And let's say these are both like 120 degrees. Keep in mind, their arcs, since they're central angles, will be 120 degrees. That means their arcs will be the same length. And if their arcs are the same length, then these segments that connect to these arcs here, these segments are also going to be the same length. Not as the arcs, we wouldn't call them 120 degrees because they're segments. We would measure them with, a length, not in degrees, but they would be the same length. So maybe they would be like 10 inches and 10 inches. And the rest of these are similar to this. Theorem 4 is the same type of thing. We're starting with these arcs being the same length or the same number of degrees. Let's say it's 100. These that hit at the same spot from where they're intercepted. These chords must be the same. And if we were to make these little central angles that make them up, going to the center of it, those center angles would be the same because they both would be 100. And the next ones are very similar to that. If we started with congruent chords, then these arcs here and here must be the same size, and the central angles that make them also the same number of degrees. So I put up some examples. So take a look at number 1. Find x. If there's a tick mark on this 104, then this 104, that tick mark must mean that those are 104. These don't have anything to do with 104. The only thing we do know about them is that these would be the same length. So the equation should look something like this. Not with the 104 involved. The 104 is helping us show that those two arcs are the same, so those two segments are the same. And then we'd have to solve. And since it said find x, we found x. So the same thing with this example number 2. The 10s don't really have a whole lot to do with the problem, just showing us that those two segments are the same. So we know that these two arcs are the same. And whatever the number of degrees they are, they'll be equal. And since we were supposed to find x, we found x. Another theorem that we can talk about today is a diameter perpendicular to a chord bisects the chord and its arcs. If this is a diameter going through the center of the circle, and this chord is perpendicular to it, then it cuts these two parts of that segment in half. It bisects it into two equal pieces, which also bisects these arcs into two equal pieces. And these arcs over here into two equal pieces. Even if you were to try, you take a different chord, okay? This chord on this next example here, okay? The center is right about there, and you try to be perpendicular. Sure looks like it cuts it in two equal pieces, and it does. And it cuts those arcs into two equal pieces, and these arcs into two equal pieces. Let's take a look at example 1. This chord shown is 8 centimeters long, and the diameter is 10. CO is the perpendicular bisector to chord AB. Find EO. This is from the old Regents, but it's still fair game. I did make the Regents that year, 2011. So right off the bat, if you know that this whole thing is 8, you might not want to mark it, because you might want to put 4 and 4. When they're perpendicular, 90 degrees, the diameter to that chord cuts it into two equal pieces. Now they tell you that the diameter is 10, but a lot of people will try to mark then this much as 5, and it doesn't get them anywhere. So I always say, try to make something you least expect. A radius here, the diameter is 10, then a radius is 5. That radius is 5. It's just a Pythagorean theorem problem, where 5 is the c squared, and x and 4 are the a and b squared. So many things are kind of hidden, easy problems to solve, but you can't use the theorem if you don't know how to, how to label this diagram and break it apart. And let's try another one. If these two are perpendicular, and this is a diameter, then it's going to cut this into two equal pieces. AB is 20, so I would label it 10 and 10. And O to E is 8. Find the length of a radius. Again, draw in a radius. Now you've got your a squared and your b squared and c squared. The radius here is across from the 90-degree angle, so that's the one we're looking to find. A couple people are not understanding this whole simplest radical form thing. You need a calculator for it. And you got to find what's divisible by what goes into evenly 164. So I know 4 is going to go evenly into it, and I think 4 is going to go evenly into it 41 times, which I don't think I'm going to be able to work any of these other ones out. Normally I would check 9, 16, 25, and I usually go up to about halfway, so I might even stop at like 81, but it doesn't work. You write the perfect square first, and you want to keep it 164. So 4 times 41 still equals 164. Then we write them each under their own house, perfect square first, and you make up that 41. You put the right number in there so it still equals 164 underneath. Square root of 4 is 2. Square root of 41 is irrational. We carry that part down. Last but not least, let's look at Theorem 8. If two chords of a circle are congruent, now we know that they make congruent arcs, that's from before, and congruent central angles, but they're also the same distance away from the center of the circle. So if that one was 8 distance away, that one would also be the distance of 8 away. If they are equidistant from the center, so if we know, and I'm going perpendicular to the center, if we know that they're equal distance away from the center, then they both must be the same measure. If one's 10, the other's 10. They could be 20, but they both would have to be equal. So for example, number 1, find x. If we've got congruent arcs, then we know we've got congruent segments here, which means they have to be the same distance away from the center. Find x, found x. And last but not least, just something that keeps on coming up. Most people get this correct even if they're guessing. If you've got parallel chords like this, doesn't necessarily mean that the arcs are the same. Notice one's 74, one's 28. But the way you enter the circle and the way you leave, these arcs would be the same. So 2 of them and the 128 and the 74 would equal 360. $79. And we can double check it too, but if that's 79, that would be 79 degrees.